Okay, let's see, we have a system like this. This is a 10 kg block and this angle, suppose, is given. This is given as 60 degree and it is both the strings are symmetrical. That means the other angle is also 60 degree. Now they are asking you what is the tension in the string. How much is the tension in the string? To do that, again we will be drawing the FBD of the block. This is T, this is T, this is 60, and there's a force mg that is equal to 100. Now if we write the equation of equilibrium in the vertical direction, you have to break this force tension into component. So this component in vertical direction will be T cos 60, and from both the sides, or both the tension, it will be 2 cos 60 degree. That should be equal to 100. And along the horizontal direction, if you write, you'll have T sin 60 degree in this direction and T sin 63 in this direction, and they will cancel out. That's 0. So from here we can find T cos 60 degree is half, right? So T will be equal to 100 Newton. So a tension of 100 Newton will develop in a string if the mass is hung in this fashion. Okay? Okay, so we are progressing, we are learning. Good. Suppose this is W1, this is W2, and this is a pulley. These are strings, and strings are symmetrically placed. This string is symmetrically placed. Let this angle be theta. W is weight. See, M is mass of a block, and M into G is the force with which earth pulls it. This is called weight. Weight is actually a force. W is equal to mg. Weight is the force with which a block is pulled by the earth. That is its weight. Now W1, meaning W1 is actually m1 into g. So the unit of W would be unit. The unit of weight will be unit. W is weight is mass into this small g. Okay, so instead of mass, weight is given. That's fine. And suppose the weight W1 is known. W1 is 50 Newton. Okay, and this angle is also suppose known to you. This is 30 degree. Now tell me, what will be the tension? How much will be the tension in the string T, and what is the weight W2? So you have to find T and W2. So it's a good initial problem for you on a very basic level. So you should try this one out. Okay, let's see how we will be solving it. You can solve it from this end. You should start from the blocks, because making their FBD is easy, and since both the blocks are stationary, so you can very easily write the equation of equilibrium for both. And since weights are given, so it's a good, W1 is given, so it's a good idea to start from here. So if you start from here and try to write the equation of equilibrium, this is T. The tension will be same in the entire rope, because we have talked it before when we studied tension. Tension is same. When the rope is in static condition, we had the discussion that the tension will be uniform. So if we are finding T here, the same T is here. So in the vertical direction, if you write the equation of equilibrium, T you will get very easily as 50 Newton. That's how this weight will be balanced. Now if T is 50 Newton, then let's come here and write the equation of equilibrium for weight 2 in vertical direction. You'll get 2t cos theta. This is equal to the weight W2. And in the horizontal direction, since I told you that the strings are symmetrically placed, so T sin theta and T sin theta will cancel each other. So W2 you can get from here very easily. Cos 30 degree is root 3 by 2, and the value of t you have already found. So weight 2 comes out as 50 root 3 Newton. Okay, so that's how things goes. So these kind of questions would be pretty simple and straightforward. You just have to write the equation of equilibrium in horizontal and vertical direction. Some of the data will be given to you, some of the data will be asked from you. So those things are pretty simple. Suppose we have an arrangement like this. Now this is a single string. This is a single string, and it was suppose hung vertically, and then we plugged the string with some force and we kept it in this position. Now the force is given as 30 Newton, and this weight, or suppose this time I'm giving you the mass. The mass is 4 kg. So you have been asked to find what is the tension here, T, and you have also been asked to find what is this angle theta. So find T and theta by writing a very basic equation of static equilibrium. Write it in horizontal direction, write it in vertical direction, and you will very easily find what is T and theta. Let's do it. If this is theta, then this is also theta, alternate angle. So T cos theta, I'm writing the equation of equilibrium of this knot here, this point mass here. So the tension if in this rope is T, then the tension in this rope is T dash. I told you this is the same rope, but the tension in this case will not be the same because there is a knot here. Somebody is plucking it by his finger and there is a difference. So the tension won't be transmitted to the other side easily. So because there is some barrier. So when you have a knot or a barrier on a rope, then the tension no more remains the same. It could be, it could not, maybe it may not be. In this case, it will not be. For the reason that if you find T dash first, if you write the equation of equilibrium for this mass in vertical direction, T dash will come out to be 40 Newton. T is equal to mg. If T dash is 40 Newton and then we'll calculate T, it won't come out as 40 Newton. So for now, we have calculated T dash as 40 Newton and we are writing the equation of static equilibrium for this point mass, this knot here. Then let's write it in the vertical direction. T cos theta. You have learned to take the component of vector in the chapter of vector. T cos theta is equal to T dash. That's the only two vertical forces. And in the horizontal direction, you will have T sin theta. On left side and on the right side, you have a force of 30 Newton and they two should be equal. T dash we have calculated as 40. So if you divide these two equations, we'll get tan theta. We'll get tan theta is equal to 3 by 4. From here you know that theta is equal to 37 degree. It's a standard angle, you should know. Tan 37 degree is 3 by 4. So from here we know theta is 37 degree. So that's good. We have found out theta. Now from putting that theta in any one of the equation, you will find out what is T. Let's suppose we put theta here. Cos 37 degree is 4 by 5. So T into 4 by 5 is 40. So T comes out as 50. T is 50 Newton, theta is 37 degree. Problem is pretty damn easy.